everyone, my name is Samantha Valentino and I am a first-year Ph.D. student at New Mexico State University working in the chemical engineering department. I work with cancer research of breast cancer, looking at metabolic changes to determine how those metabolic changes can help us look at treatment. So when we think about cancer, a lot of times we have this idea that, okay, treatment doesn't always work. Well, that's because cancer has a tendency to become unresponsive to treatment, and that's what we call resistance. So what we do in our lab is we're looking to see, can we track when somebody is going to be developing resistance to their treatment? Can we look at how their cells are making energy either in glycolysis or oxidative phosphorylation, and looking at the metabolic changes of those two to see, can we see where we need to start going off on another treatment area? So the way we look at metabolism changes in our research is that we have this machine called a flow cytometer. And what it does is it takes a laser and it passes a laser through cells. And naturally cells have something called NADPH, which is autofluorescent within that cell. I can put a laser through that cell and it will be excitable and it will give off light. And what we call that light is fluorescence lifetime. And fluorescence lifetime is the amount of time that that NADPH is going to be in an excited state before we're turning back down to the ground state. And when it's bound, we have a longer lifetime, and when it's unbound, we have a shorter lifetime. So those two bound states actually indicate what metabolic process that these cells are using. Glycolysis will have that short lifetime, and then oxidative phosphorylation is going to have that longer lifetime. So we can use those two states, and we're going to try and see, like, okay, do resistant cells have higher or lower lifetime than our cells that are still responding to treatment? And as we develop resistance with our breast cancer cells, is their metabolic state changing? Are they having a longer lifetime as they move towards resistance, or is their lifetime decreasing as it moves towards resistance? Can we track those changes as a way to help doctors determine, okay, let's move to new treatment, or we can keep going with this treatment, it's still working. So that's kind of what we want to do with our machine, is help track the progression to resistance and see if we can help people with their treatments. Thank you everybody for watching. If you're looking for more information, feel free to contact the chemical engineering department or Dr. Jessica Houston, who runs the project that I work for. Thank you for your attention, and go Aggies.